So what sort of information can we get from the atomic orbitals, from the functions that we get from the Schrodinger equation? Well, for one, you can get the probability of finding the electron in a particular region, right? What would that be? That would have to be the integral of what? Psi star psi d tau would be integrating over all space would be equal to 1. So you're going to have to do your integration here. So it's going to be r squared dr from 0 to whatever r, from r1 to r2, let's say. Okay, and then you integrate with respect to theta and phi. So you have d theta. You multiply the thing by sine theta and integrate from 0 to pi if you want all possible angles, right? And you integrate d phi from 0 to 2 pi. So this, for example, would be the integral, would be the probability of finding the electron within a spherical shell of inner radius r1 and outer radius r2. So the probability of finding it in that shell, that would be, so you're integrating from r1 to r2, but you're also integrating over all possible angles. So theta 0 to pi and phi 0 to 2 pi. So that's one example, okay? And you can calculate probabilities of finding it at certain angles, certain ranges of angles, so you can just change these limits and change these for theta and phi and r, okay? So in general, your probability would be what? Integral from, okay, integral of psi star psi multiplied by r squared dr. You can go from r1 to r2, okay, and multiply by sine theta and integrate over theta from theta 1 to theta 2. So this makes it generic, right? And integrate over phi from from phi 1 to phi 2. Okay. Now, if you set r1 and r2 as 0 to infinity, and you go from theta equals 0 to theta equals pi, and from phi equals 0 to phi equals 2 pi, then the whole thing is going to be equal to 1. Total probability. All right. You can also calculate the energy that you need to excite an electron. Okay, line positions in your emission and absorption spectrum. Remember, we said what's responsible for spectral lines in your absorption and emission spectrum? Transitions between allowed energy levels. Since we can calculate the allowed energies, we can calculate those spectral lines. You can calculate the energy needed to remove an electron from an atom, the ionization energy. Okay, we'll talk a little bit more about that later. You can determine how the electron would react in response to an external magnetic field. Okay?